my name is Cassie Kozyrkov, or if you can't pronounce that, Cassie Coffee Pot will do just fine. And I blog a lot for your amusement. My Twitter handle is up there, and if you're interested in any further reading after today's talk, a lot of it is written up in articles, blog posts, and I go a little deeper. So if you want to share any of it, if you want to read more, after this talk, after we have the sort of Q&A hangout session, which is going to happen outside this room, I invite you guys to just come hang out with me if you want to. After that, I'm going to post a set of resources and links for you, so follow me on Twitter, and if you're interested in that, and that'll come up shortly. All right, now, I'm interested in you, my friends. So can I have a show of hands if you self-identify as an analyst? Okay, lots of hands, thank you. Self-identify as a statistician. I myself am a reformed statistician. Reformed statisticians also welcome for this category. Okay, great, fewer hands. How about machine learning engineer? Okay, machine learning researcher. Data scientist. Data engineer. Leader. Okay. Who here put their hands up for more than one category? Okay. I say about a third of you maybe, more than one category, more than two categories. Okay. More than three or more. Okay. I see, interesting. This is gonna be relevant shortly. Now, however many you are, the third or half of you that self-identify as data scientists, this talk is all about making you useful. Well, let's talk about making data science useful, but before we do, what on earth is data science, other than that term that no one bothered to define and now everyone's got it on their resumes? Which, by the way, most of the people that I know that have had the job title data scientist, myself included, the moment when we got that job title, it wasn't a new job or a promotion. We were doing some work, being called something or other. I was called statistician at the time. And then the job title changes and the work doesn't. Isn't that amazing? You probably have that experience too. So what is this data science thing that no one bothered to define? Is this statistics on a Mac? Silicon Valley statistics? Statistics where you can kind of code, or coding where you can kind of statistics? Who knows? The definition I like is that data science is the discipline of making data useful, which should trouble you, because my talk is titled Making Data Science Useful. And data science seems to be about making data useful. And there's so much data. What on earth is going on here? Isn't it automatically useful? Why do we need to talk about this? Oh, but we do. You would be amazed how often folks come up to me and ask me, is data science a bubble? Interesting, I'm going to get to that. I have leadership teams in large companies saying, our data scientists are useless. They just sit in a room and produce white papers. What are they even for? And I have data scientists coming up to me saying that they struggle to justify their value to their companies, that they feel like imposters on the job. Very troubling indeed. So I think that it's about time that we own up to the fact that data science has some problems. At least 3 problems. And these problems, don't worry, there are solutions too. These are the problems that we're going to tackle today in this talk. So here they are, you ready? Problem 1, making. Problem 2, data. Problem 3, useful. Let's do this in order. First off, making. The data science universe is expanding very rapidly. And there is this strange myth that still persists, even though there's so much activity and so much innovation and so many new tools in this space and so many different approaches and algorithms and problems and things you can do with data. There's still this myth of the data everything person. Companies think that they can hire you and you are now suddenly the data everything person and you have to know the everything of data. And if you just take one moment to examine that, you will realize how completely ridiculous it is. However, I bet a lot of you are still carrying around this feeling that maybe that is what you should expect of yourselves. So maybe the subtitle for my talk is "No Wonder You Have Imposter Syndrome." Once upon a time, it was reasonable that you might be able to know everything that there was to know about data analysis and statistics and whatnot. Now, not really. Who here knows what this is? Okay, who here has held one of these? Very few hands, okay. And do you know, who here knows how to use them? Amazing. Okay, 2 people. Do you put your punch card skills on your CVs and you don't work for museums? Okay. But once upon a time, this was the height of being hardcore at computer science and data. And now it would be a joke to have that on the resume. And there's no more strutting. Look at me with my punch card skills. Look at me with my TensorFlow skills. You see where this is going. The thing with this is that the tool Am I speaking? Oh, okay. Right. Just, all right, you're in charge. Just like wave at me if I go quiet. Cool. All right. So what was I even talking about? I forgot. Different talk, next talk. What was I saying? Goodness. This is great. We're going to improvise the whole thing from here on out. Right. There's a reckoning coming. And it's because industry has noticed that data can be useful. That's thing 1. And thing 2, a lot of it is being collected. And because of that, maybe it makes sense to start enabling people to make use of it. Maybe it makes sense to start building user-friendly tools that people could use to get on with it so it's not so difficult, so the barriers to entry go down. Now is a time when suddenly data science is a term that is thrown around by at least the user experience designers that I know, which wasn't really true a little while ago. The data scientist as a user wasn't a thing. In fact, the data scientist stereotype is that hardcore person who loves to think of themselves as the kind of person who probably, could make their own vacuum tubes and put together their own computer and compose their own operating system and do it all from scratch and, reinvent backpropagation and all that all by themselves. And you like doing it the hard way because the more you sweat, the better you feel about yourselves. I know, I was there as well. I loved boasting about how I was up all night with some measure theory or whatnot. Guess how often I use measure theory on the job? Except for mentioning it as a long-gone horror. Not much. So we are the sorts of people, many of us, who like to do things the hard way. We like it because it's difficult. But some of it is difficult not because it's intellectually challenging. It's difficult because the tools suck. It's difficult when the tools are that. It's difficult when the tools are TensorFlow 1.x. For those of you who know that one, let me just go ahead and let me be a loyal Googler, just throw Google right under the bus. TensorFlow 1.x was about as huggable as a cactus. Like, it was a thing that you tolerated. It wasn't a thing that you loved. I get it. Now, TensorFlow 2.0, which is TensorFlow plus Keras, and that came out of beta last month, that is a lot easier to use. And the reason that is going that way is that fundamentally the philosophy of the folks involved there was not that 1.x is all about sadism and let's make the people suffer. It was new ground that was being broken with tools. And then with this wave of let's make the user experience of data scientists not be horrible, that attitude is baked into trying to make better and easier tools, where all that annoying boilerplate gets put aside because that is frankly not the fun part of the job, or the interesting part. It is the hard part, but what kind of hard is it? And I want you to ask yourselves, how much of your work is that kind of hard? That kind that is chores. And do you believe that that part is going to stay the same over time? And if you're really proud of having mastered that fiddly, annoying stuff, is that claim to fame for you going to stick around for your career? What I want to ask you is, if there is a big movement, and I believe there is, I believe this is the trend to watch, barriers to entry to data science going down, to the tool using at least, because of better platform engineering, better user experience design, better tools. The question I want you to start thinking about is, what happens to data science and data scientists as the tools get easier? What's left over when the fiddling goes away? And you know what? My answer to this is a hang of a lot is left over. Because the interesting and valuable part of your job is not wrangling punch cards. It's not even engineering, it's interpretation. There is this squishy human core that is about understanding and about turning information into better actions in different ways. That is where the essence of our disciplines actually lies. And all that stuff gets sort of barnacled in this crusty, ugly, choresy stuff that is not actually what we're about. And sometimes we forget to see the forest because we're so busy with these little fiddly trees. So this talk, part therapy session and part call to arms, is a bit of a wake-up call to have us as a community really think about what data science is, and also acknowledge the fact that it is not all the same thing. When you strip it down to its core, it is actually very different excellences and activities, very different personality types. And what I think we should start doing is we should start appreciating those differences, and we should start growing the people to be excellent in their versions of these disciplines, rather than putting pressure on them to learn some particular tool sets or to be something else in this space. So I want to talk to you today about the makers. That's in our problem one, to acknowledge who these makers are, to try to understand them and try to understand their differences. So here's the data center full of data, and we want to make this data useful, presumably. What can we do with it? So here are some ways we can make it useful. We can look at it. We can look beyond it. And we can use it to fuel automation. Great. The different training programs out there, and you're going to hate me because I'm going to say an opinionated thing right now, and that's cool. Let me just own that. The training programs out there that are most likely to both attract and produce folks who are good at these different activities, better at one than at the others, shake out as follows. Analytics and analysts tend to be pretty good at the exploration side. What is in our data? What is right here? And how does it inspire us? Going beyond the current data is what statisticians are all about. And automation with the data is the machine learning / AI racket. By the way, I hope you will indulge me in this talk. I beg your indulgence. I will be using machine learning and artificial intelligence interchangeably. I'm an ex-academic. I get that they are technically not the same thing. But quite frankly, industry uses them as synonyms. I give up. It actually doesn't matter at the beginning of your applied project which one it is, because you start them both the same way. If you need a neural network, try the line as well, for goodness sake. It's like, what, 2 lines of code? And also, because I want to share with you my new favorite definition for the difference between machine learning and AI, here it comes, if it is written in Python, it's probably machine learning. And if it is written in PowerPoint, it is probably AI. A little humor to wake you up there. See, this is in PowerPoint, so I will proceed with my synonyms. So let's talk about the three excellences in this space. Let's talk about these three disciplines as three personality types and what those excellences embody. And where this is going to go is it's going to go towards a question for you of, do you really believe that you can expect, that you can demand workers to embody all three of these? Or would it be a little bit of a case of multiple personalities there? And aren't you asking for a lot? And maybe there are folks, I've met them, I may or may not be one of them, who embody, to some degree, multiple. But I want you to realize that it is rare. And maybe it's actually better to be an expert in one, to really not be bullied by folks who do this a little differently from the way that you do it. And I'm talking about the applied side here. I'm not talking about the academic research side. I'm not talking about the creation of general purpose tools for other people to use in the sense of the blueprints, or in the sense of the user experience design and platform engineering of actually making the tools that you will use to run your whatever they are, tests of proportion, neural networks. So I'm talking about the applied side of solving real-world problems with data. So let's look at the three excellences with some example tasks. So here's a machine learning tasks done on Google Cloud, or AI task, let's call it that. And here the game is all about making it work. That's what we are after. This is automation. And the simplest way that I have found to explain machine learning to folks is like this. Traditional programming, you take inputs, you turn them into outputs. That's what a computer does. Via something in between, a model or a recipe. And that model comes from the human programmer communicating with the universe. That's how they do it. They think really hard about the nature of the problem. And then they come up with the steps, and they put them in the language that the computer understands, and they have written the model out of nowhere, out of, that sounded good. Machine learning is about expressing that model not with direct, explicit instructions, but instead with examples, and then having the algorithm find patterns and turn that into the instruction code. So if you've ever wondered whose job AI and machine learning actually automates, it is the software engineer's job. But never fear, there is plenty of software engineering involved in moving all that data around and getting the algorithms to play nicely with it. But this is all about expressing our wishes with examples rather than instructions. That's what it's about. It's about automation. The game here is to make it work. And so a real example is of some thing labeling, I also like to call it thing labeling with data, is a problem of diagnosing diabetic retinopathy. So doctors will label eyes as healthy or diseased, and then from the images, the system has to predict which one is which. An automation task. So what's the excellence here of the person who does this? Does it make it work? This is an excellence of performance. This is fundamentally engineering. And this kind of person, if they just want to make a prototype that works kind of nicely on the data that you have in your attic, they're not really good at that job. This is about performance, not just in prototype, but in production. Potentially at scale, with all the other systems that your system has to interact with. This is hardcore engineering. Next up, statistics. Statistics is about going beyond the data. How I like to compare statistics and analytics is, if you want good answers, you go to statistics. If you want good questions, you go to analytics. Statistics may potentially give you some very good answers to some very silly questions. Statistics is kind of that game of you form a hypothesis, if you don't use analytics, possibly from nowhere, by meditating in a closet, you kind of set things up, and then you carefully, rigorously come to some conclusion, or don't. Statistics is the science of going beyond your data. Say I'm all over the place after that little moment. Statistics is the science of changing your mind under uncertainty. There, now we got it. It is also the science of going beyond your data. It cares more about what's beyond your data than what's in it. Fundamentally, it is dealing with the great unknown. And it's the science of changing your mind in this sense. If you're a frequent statistician, you change your mind about actions. You have some default action you're happy with. You ask yourself, in what world are you happy to do that action? That's your null. Then you ask, what are all other worlds? There's your alternative hypothesis. And then you ask, does my data make me feel stupid? Persisting with my default action, behaving as if I live in this null world. And if the data makes you feel stupid, you change your mind. Otherwise, you don't. You just keep doing what you were doing. That's the frequentist setup. How about Bayesians? What do Bayesians change their minds about? Not actions, but instead opinions. You have an opinion. You can express it mathematically. Now you get some data, and you can change your opinion in a sensible and reasonable way. So again, it is the science of changing your mind, both ways. And for some reason, people think that you can make certainty out of uncertainty with statistics. If you just do the correct ritual dance, you get some fancy confidence intervals and p-value things out the other side that all looks very rigorous and legitimate, and it legitimizes your science, and there's no magic that can make certainty out of uncertainty. The way you go from what you know to what you don't know is like that. You add a bridge of assumptions. What are assumptions? It's some stuff you made up, basically. Something you thought was reasonable, some scaffolding for your decision. That is up to the decision maker. There is, in fact, no correct way to make assumptions. It is whatever you feel is reasonable to assume for your decision, then you add data, and off you go. If you are going to play with leaping beyond what you know to what you don't with this bridge of assumptions, it kind of matters that you're very careful about how you set those things up. And you think very carefully about what all those assumptions mean and what you're doing and what all this context actually does so that you can ask yourself how data changes your mind about it. The excellence of a statistician, then, is the excellence of rigor. And your statistician, I know I'm still recovering, is quite often the brakes on your team's exuberance, because a statistician prefers to come to no conclusion rather than to come to the wrong conclusion. Prefers to learn nothing rather than to learn something stupid. Slow, careful, rigorous, meticulous. And then, how about the analyst? Here's an example that I really like of analytics. Our scene is set actually in London. This is a map of Soho. And this is a map from the 1854, I think, cholera outbreak. And back then, people thought cholera was transmitted by polluted air. And that was how we got around. And then this fellow, analyst, Jon Snow, not the Game of Thrones one, thought, why don't we look at where the cholera cases actually came about? And then was inspired to realize that, there's the Broad Street water pump. And this all seems to be radiating around the water pump. Maybe it has something to do with water, in fact, and not air. And from that piece of inspiration, the medical profession was then inspired to wonder whether maybe water was something worth investigating. This got the good question that then could later be followed up statistically to get the good answer. From only this, you can't prove anything. You can't prove that it for sure is the water. But this inspires you to think about things that you might not have thought about. Analytics is where the good questions come from. It's where you start getting a handle on those unknown unknowns. And inspiration shouldn't be underrated. And what's the excellence of an analyst? It is speed. And it's speed in all kinds of flavors. It's speed in surfing through a really large data set and figuring out what's in there. In fact, for that reason, an analyst needs to have probably even better grasp of the mathematics than the applied statistician or the applied machine learning engineer, because the others can kind of just look up the math and methods that they need, but this person is trying to project a big, messy data set down into a simple summary that tells them what was there that they couldn't have looked at with their eyes. They kind of have to understand how that math does that projection. Another kind of speed speed of getting it from the screen into their own brains. Visualization techniques are important for that. And then also speed of communicating it and inspiring decision makers. Just because it's kind of interesting to them doesn't mean anyone will do anything useful with it. So it's all about speed in all kinds of forms. And the analyst, I want to defend analysts here. Analysts get a lot of abuse, especially from machine learning folk, about how rubbish the code is. A lot of abuse from statisticians about how, like, are those errors normally distributed? Wrong questions, my friends. An analyst should code in a sloppy way on purpose, because this is not supposed to be robust and reproducible. This is supposed to be as fast as possible. And the only thing they're going to code up nicely is their own little quick exploratory sweep that they reuse over and over. Because if it makes them faster, then code it better. Otherwise, don't. Write it in the sloppiest possible way. When I'm in analyst mode, I'm sitting there at 2 in the morning, like bashing on my keyboard. I hope I don't find anything interesting, because I'm going to have to refactor this mess. So you kind of have to understand that speed is what the game is. And there is a different excellence of good coding for analysts. And it's really analytics noobs who are good at one of the other disciplines who will go and abuse the poor analysts. And there is a nice round robin of abuse. It's beautiful to watch. You've got the statisticians telling the machine learning engineers that they're idiots for thinking things work that don't work and then testing on training data and all kinds of good stuff. Yep. And you've got machine learning engineers telling statisticians they can't code their way out of a paper bag and telling analysts that what is this rubbish quick code. It's a marvel, but it's a marvel, so it's a sad marvel, that comes from people not understanding that these are different jobs. And they take different personality types. And if you're going to be the true data scientist who does all three, you're going to do some sloppy analytics coding, then you're going to go into your machine learning mode and you're going to write beautiful, professional, high-grade software engineering quality code. And then you're going to poke around as an analyst in the data, get inspired, don't worry about it. All you care about is what's here. Who cares if those errors are normally distributed? That's not what we're dealing with. And then you turn around and you go from speedy to slow, pedantic statistician. It's kind of hard in one person. It happens. But do you actually want to staff your team like that? Do you want to insist that everyone that you hire for your data science division does all three? But wait, there's more. There's 2 more. There's the leadership side and the data engineering side, which is the topic of my next 2 sections, which I'm going to get through pretty quickly. But I want to say one last thing in defense of analysts who get the most abuse, so I feel that someone has to speak up for them. Machine learning engineers and statisticians, they do specific things to solve specific problems in a narrow and deep way. That is the shape of a rabbit hole. Make sure that that rabbit hole is worth going down. If you don't know where to dig and you just start carefully solving some particular problem because someone throughout your 20 years of schooling or whatever got you used to thinking that it has to be right or else, you're wasting a bunch of time if that's the wrong problem. Whereas analytics is how you figure out where to dig. It is that broad and shallow sweep, which, if you turn your mind sideways, is as deep and narrow as the others. Analysts, to be experts at their game, need to know as much as the other 2 do. All 3 are equally wonderful and valuable. They're all useful, and they all should be appreciated. So I just want to remind you, data science is a team sport. If you only have statisticians in a new area where those X's aren't marked on the ground for you, and no one's got analytics skills, it's going to be a slow dig down a rabbit hole that goes nowhere. You don't want that. Same with machine learning engineering. Now, going faster. Problem 2, data. I wish that the next scene were an isolated incident. It is unfortunately not. More than once, someone has come to me and said, I have been hired to be chief data scientist at a company that has no data. What do I do? Okay, here's the thing. Data science doesn't make sense without data. You can't make data useful if there isn't any. Now, if you think of data science as making data useful, then data engineering is making data usable, or making data. And data science can inform, since data science is the client of data engineering, can inform the design of data collection and so forth. But at the end of the day, when we are talking at massive scale, data engineering is a sophisticated discipline in its own right. Let me explain. You know how going to the grocery store and getting a pint of ice cream is easy? That is how data engineering is easy when the data are in a spreadsheet, or they fit in R or whatever. Now, what if the problem is get me 20 million pints of ice cream by tomorrow and don't let them melt? Is it easy now? Did your trips to the grocery prepare you for this? Probably not. There is lots that you need to know, and you don't know it. That is the nature of data engineering. And if you take a typical data science or data sciences, one of them, analytics or statistics especially, if you take those training programs, for ease of grading for the professors, the data tend to be small. And you are not prepared for this game. And if you are hired then to be the first and starting data scientist because you are the data everything person, you are going to suffer. Now, maybe you are brave and then you're going to go and learn data engineering because you want to learn all the things and you don't want to share, and it's not a team sport anyway, so don't collaborate, do it all yourself. No. Maybe if you are the first person, you're going to have to learn this stuff. But while you're doing that, you are forgetting the stuff that you studied that made you a data scientist in the first place. And then you are managing more people, and all of a sudden you are a manager, and all those fancy neural networks that you were into, you never got around to doing that. Now someone else is doing that. That happens quite often, and that's again a misunderstanding of this whole notion of the everything of data. This is a different thing. Forgive yourselves and partner with people who know how to do the part that you need. And if you are hanging out here and you're about to do a startup and you're just checking out what this data science thing is, hire the data engineers before the data scientists, for goodness sake. Or hire them together. That's probably best of all. Next up, all this stuff about AI bias. On and on, I'm sure you've heard so much about it. AI bias comes from the data, say people. AI bias comes from people. You know why? Because data comes from people also. We forget that data is made by humans. It's essentially a textbook. In fact, a textbook is a data set. It's just when you put it into electronic format, then it looks a little more like a data set. It's really annoying to search. If you've got a paper book and you go, abracadabra book, how many A's are in this book? Whereas if it's in electronic format, now it's called a data set, abracadabra, how many A's are in this data set? That's much easier. But a textbook is a data set is a textbook. And I want to remind you that we laugh at people who say, well, if it's written in a book, it must be true. That's the dumbest thing ever. And yet, you have this whole host of people today who are like, it's in the data never lie. It's in the data set, it must be true. I mathed on it. I did some heavy mathematics, and now the truth has come out. Those data come from humans. They are what some humans bothered to notice and bothered to write down, and it may or may not be useful or helpful. Just because you have data doesn't mean you have something good there. Just because I have a book doesn't mean that this book is going to teach me architecture. Who knows what kind of book it is? And who knows what kind of, even if the author claims to be an architect, even if it says architecture on the cover, who knows what kind of stuff is in there? You've heard a lot about AI bias, so I'm going to give you the Hemingway lecture. 6 words on AI bias. The whole problem and the clue to the solution as well. AI bias. AI counts for 1. AI bias. Inappropriate examples never examined. That's the problem right there. Someone wrote a book, and you picked up this book, and you treated it like it was made of magic. Everything about it was true and factual, because the next thing that happened was someone did some mathing on it. And meanwhile, maybe that author was prejudiced. Maybe they decided to notice a whole bunch of things which were not the right things to notice and forget to notice some other things. Maybe the things that they put in, maybe it was about humans and they forgot a whole swath of humanity and just put a select kind of person in there. When you read books that are from a century ago or even earlier, you do get this sense of like, oh my goodness, who are these authors? Similarly, when you start to read data sets today, you will get that sense, and you should. And we should all worry about this. AI bias comes from people. What kind of teacher, this is what I want to ask you, what kind of teacher just takes those textbooks and assigns them to their students and doesn't worry about what's in there? That means you have to have analysts looking, opening the textbook, seeing what's in there, checking for red flags. That is really important. But how do we avoid problems with bias? Well, you can't fully avoid problems with bias. AI bias, it's not statistical bias in that sense of systematically off the mark. It's that more human thing. Algorithmic bias is when the algorithm reflects humanity's implicit values. Well, everything that we do, everything that we notice, all data, it reflects humanity's implicit values. And I don't think that we've stopped growing as a species. In 500 years' time, are we going to feel happy about things that we thought were fair and good today? I imagine we'll think that we were a pack of barbarians. Still, even if you can't aim for free of human, some human stuff is always going to be in there. It doesn't give you a license to be a jerk. And it also doesn't give you a license to be negligent. You owe it to your world to think about what those textbooks are, to think about who wrote them, and to open them with analytics and to have a look. And if you have more authors involved in the design of the textbook who come from different perspectives and backgrounds, it's more likely that your textbook is going to reflect some decency. And if you have analysts who come from different backgrounds, who are checking whether that textbook is a horrible thing, you're more likely to catch badness as well. You don't have to wait until your student is out in the world embarrassing themselves. This is why I like to say that, especially in AI and machine learning, but really in all of data science, diversity is not a nice to have. It is a must. It is through a diversity of perspectives that we actually catch the problems. Otherwise, a single individual might find themselves agreeing with a single author, both of them biased in the same direction and completely blind to it. We have to own this human side as well. And then problem 3, useful. This was the taxonomy I gave you before, but one I like even more is this one. Many, few, none. Any guesses what many, few, and none stand for? Many what? Data points. I love this answer because it brings comedy. Thank you for playing. When we have no data points, analytics is a little bit hard. It can't be data points because you can't analyze no data. So instead, what it is decisions. When you know what decisions you want to make under uncertainty before you begin, that's automation. You are making you're making a model that's supposed to handle many decisions with the data. A few important decisions, or maybe just one, like launch this medication or don't, launch this machine learning system or don't. That's what your statistical inference goes and helps you with. And if you don't even know what you want with this data set, you don't know what decisions you want to make, then the best that you can hope for is inspiration. And then you need a good way to get inspired and a good approach. Machine learning, AI, statistics, analytics, they share the same mathematics. They share the same tools. It's not the tools or the equations that define them. And if you wanted to prove a point, you could go and do some horrible looking things involving inference with neural networks or whatever else. What defines them is how they are used for decision making. And that, in fact, defines the process, the design of the process. that you should take to go about doing these activities successfully to solve business problems. But all of this is predicated on your knowing in advance how many decisions it is that you want to make. And who is in charge of knowing that? Is it the data scientist? It is, in fact, the decision maker, the leader of the project. And the person who is often missing, and the person that you need to get this done properly so that data science can be useful. Because without decision makers really framing what they want, being able to communicate to data science teams, you think you're building this. You're actually building that. And it's a bridge in the middle of the ocean that starts nowhere and goes nowhere very rigorously. It is so sturdy. But it doesn't help the world very much, and it doesn't make data useful. You need that leadership, and you need those leaders. But where are they going to come from? Are we expecting the data scientists to spend their whole lives learning something else? The math, the tools, the data? Are they just going to transcend one day and start thinking about the business and how to make data useful? Who's training these people? I'm trying my best to. But we need more of this, and we need people to recognize that leadership in this space is its own discipline, and it is a valuable discipline. And maybe we should reward students a little more for being interested in, oh goodness, should we call it the soft side of data science, rather than learning their 7th programming language. If we need a new standard for what is hardcore, maybe learning those things is important. But where are you going to learn them? I mean, stats courses, I took many of them. Almost always, the hypothesis is made for me by the professor. I don't learn how to set that up. Am I just going to figure it out on the job? Maybe through a few years of pain I will. That's how it's done today. But I ask you, somehow, there are data science leaders. We don't deserve them, many more than we deserve, because we don't train them. Let's start trying to train them. Let's, those of us who know something about this space, champion it and encourage these skills. And instead of allowing people to talk about the soft skills in data science like it is something flimsy, why not think of them as the skills that are actually hardest to automate? And the skills that might last when some of those tool wrangling things get automated and easy. Data science needs skilled decision makers. It doesn't have many today. And if you are in a company where you are struggling to add value, it may in fact be because no one around you knows this part. And this is the part that you need to get it done. So maybe you could start upskilling in another area. Maybe you could also start to forgive yourselves or look for spaces where people are taking this part of the discipline seriously. At the end, I want to ask you never to forget the human side. We're so excited. I'm excited all the time by new tools, new software, new equations, new algorithms, new research papers. It's all so cool. But it lets you forget the human side. Please don't. Our world is collecting more data than ever before, and we really owe it to that world to make that data useful. So please focus on the people. Focus on the people and the human side that make it useful, and do it in the reverse order. Useful first. Decision makers. What is it for? Why? Don't go leaping into the algorithms before understanding what we want to do with these things. Then the data. And who made it and where did it come from? And then we can go and make, and not the other way around. Thank you so much. If you want to come hang out, I'll be out there.